Morning to all. Today we shall discuss about the comparison tests. First comparison test. Comparison test 1. Statement. Let summation of un and summation of vn be two series of positive terms such that two conditions. First one, summation of Vn is convergent. Second condition, un is less than or equal to k into Vn. Un is less than or equal to k into Vn for all n, except perhaps means suppose, except perhaps for finite number of terms here k is greater than 0, where k is greater than 0. This is the statement. Two series are there, summation of un and summation of vn are two series of positive terms. Then that series quota, then first one condition is summation of vn is convergent. Given condition, summation of vn is convergent. Second condition, un is less than or equal to k into vn. These two conditions we can prove the two series are convergent. Then proof. Then summation of un is also convergent. Summation of un is also convergent. Summation of vn is also convergent because limit n tends to infinity Sn equal to L. Again, let un is less than or equal to k into Vn. Second condition, k into Vn for all n. Then Sn and Sn. Then Sn and Sn be the n partial sums of summation of un and summation of vn respectively. Respectively means ಇದು un sn n partial sum ಇರ್ತದ, vn small sn partial sum. Then Sn equal to, capital Sn is equal to n terms means u1 plus u2 plus u3 plus so on plus un, and small sn equal to p1 plus p2 plus p3 plus so on nth term vn. Sn equal to n partial sum of summation of un, u1 plus u2 plus u3 so on un. Small sn is the nth partial sum of pn. Small sn is equal to p1 plus p2 plus p3 so on pn. Since pn is convergent, because condition 1, summation of pn is convergent because condition 1, and that is limit n tends to infinity sn equal to l. Sn is equal to small sn is equal to l is finite and unique quantity. Now Sn is equal to u1 plus u2 plus u3 plus un. Capital Sn is equal to u1 plus u2 plus u3 un. Then we shall write also less than or equal to this condition, less than or equal to k into pn, also less than or equal to k. pn is p1 plus p2 plus p3 nth term pn. Okay, Sn equal to Sn is equal to less than or equal to k into small sn, because v1 v2 pn is equal to Sn is there. This term vn is equal to Sn. Now applying the limit, therefore limit n tends to infinity Sn is equal to k is the constant, limit n tends to infinity Sn. Hence limit n tends to infinity Sn is equal to k into L, because limit n tends to infinity Sn is equal to L. Then thus the sequence Sn is convergent. Thus sequence Sn is convergent. Capital Sn. This is convergent. Then thus the sequence Sn is convergent. This implies summation of un is also convergent. Here we take the first proof. summation of un is also convergent because the applying the first condition. Un vn are the two series of partial sums. Summation limit n tends to Sn is convergent. Summation of un is also convergent. We taking the first condition. Next, second condition, let un is less than or equal to k into vn, then Sn and capital Sn and small sn. We are denoting the by the identification Sn and Sn be the nth partial sum of the summation of un and vn respectively. Nth partial sums means Sn equal to u1 plus u2 plus u3. Un is the nth partial sum of summation of un. Next, small sn equal to p1 plus p2 plus p3 vn are the nth partial sum of summation of vn. Since summation of vn is convergent because condition 1 is summation of vn is convergent. That is, convergent means limit n tends to infinity Sn equal to L, finite and unique quantity. Now Vn means Sn, small sn is convergent. Now we take the capital Sn is equal to n partial sum u1, u2, u3, un. We are applying the second condition. Un is less than or equal to k into Vn. Is less than or equal to k into p1 plus p2 plus pn is plus so on pn. Next, Sn is equal to k into Sn, applying the limit n tends to infinity, capital Sn equal to k is outside constant, limit n tends to infinity, small sn. Hence, limit n tends to infinity capital Sn equal to k into L, because this is the L, finite quantity. Now, thus sequence Sn is convergent. It is finite quantity, thus the sequence capital Sn is convergent. Then the sequence is convergent, series is also convergent. This is the first comparison test. Now we shall study about the second comparison test. Comparison test 2. Comparison test 2. Let summation of un and summation of vn be two series of positive terms such that first condition, summation of vn is divergent. Here summation of vn is divergent. First condition. Second condition, un is greater than or equal to k into vn. In reverse condition ಬರ್ತದೆ. ಫಸ್ಟ್ ಒನ್ ಏನೈತ್ರಿ vn is divergent ಬಂತು, ಅಲ್ಲೇ ಕನ್ವರ್ಜೆಂಟ್ ಇತ್ತು. ಇಲ್ಲಿ ಲೆಸ್ ದನ್ ಆರ್ ಈಕ್ವಲ್ ಟು ಅಲ್ಲಿ ಇತ್ತು, ಇಲ್ಲಿ ಗ್ರೇಟರ್ ದನ್ ಆರ್ ಈಕ್ವಲ್ ಟು k into vn ಬರ್ತದೆ. Except perhaps finite number of terms where k is less than 0, where k is less than 0, then summation of un is also divergent. First condition, summation of un is also divergent because two series are series having the positive terms and limit n tends to infinity Sn equal to L, finite quantity. Summation of n is also divergent. Then second condition, let un is greater than or equal to k into Pn for all n is the second condition. Here, yes, again let Sn and Sn be the series sequence of Sn and Sn be the series of be the nth partial sum of be the nth partial sums of summation of un and summation of Vn respectively. Then Sn equal to same n partial sum means u1 plus u2 u3 up to enter un, and small sn is equal to p1 plus p2 plus p3 up to pn. Next, your condition is this condition, un is greater than or equal to k into pn, means here pn is convergent, that is limit n tends to infinity pn is equal to, another divergent means diverges to infinity, infinite. Now Sn is equal to, capital Sn is equal to u1 plus u2 plus u3 plus un. You see un with the nth partial sum. This is less than or equal to, this is un means un is less than or equal to k into pn means p1 plus p2 plus p3 up to enter pn is less than or equal to k into p1 plus p plus pn is small sn. Okay, here un is the capital Sn is greater than k into Sn is the finite quantity L, because limit n tends to infinity Sn is equal to L. Sorry, L is divergent irodrinda infinity, they are also infinite. Therefore, limit n tends to infinity Sn is equal to limit n tends to infinity small k into limit s tends to is small in n. Hence, limit n tends to infinity, s n is equal to k into infinity. Means the series is convergent. Limit n tends to infinity, s n is equal to infinite. Means the sequence of n partial sum, capital Sn is the sequence of n partial sum of summation of un is divergent. Means the sequence is divergent. Hence, the series summation of un is also divergent. This is the second condition. In comparison test 2, summation of un is divergent, summation of un is also divergent, because limit n tends to infinity, sn is equal to ಏನಾಗಿರ್ತದ್ರಿ infinite. Vn is divergent, un is also divergent. First condition. Second condition, this condition, un is greater than or equal to k into Vn. ಇಲ್ಲಿ same ಬರ್ತದ, Sn and Sn are the n partial sums of summation of un and Vn. Next, Sn is equal to nth sum u1 plus u2 plus u3 so on un. Small sn is equal to v1 plus v2 plus v3 so on vn are the n partial sums of capital Sn and small sn. That is, limit n tends to infinity, vn is equal to infinite, because vn is divergent, already given statement. Now Sn is equal to u1 plus u2 plus u3 un. Next, Sn, capital Sn equal to un is greater than or equal to k into P1 to Pn is called the small sn, n partial sum. Next, Sn is greater than or equal to k into infinite. Infinite means because limit n tends to infinity, small sn is infinite. This is the condition. Applying the limit n tends to infinity, capital Sn equal to k into infinity, means limit n tends to infinity, capital Sn equal to infinite. Infinite means Sn is divergent. Sn is the sequence, Sn is divergent, the series summation of un is also divergent. These are the two comparison tests. Again, third comparison test is also there. We shall discuss about the next class.